Welcome to this subsection on performance measurement. The metric we're going to use to measure the performance of our model is the accuracy. So we could use the same, or we could include an evaluate function or method in this model class, which will permit us evaluate our model. We define this evaluate method, which takes in x, that's our inputs, and with the target output, we are going to compare what our model outputs with this target, and then from there give an accuracy for our model. Now, to obtain the output predicted by our model, we pass this input x into this forward method, and we obviously get the output predicted. So we could say this is predicted output. And then from here, for each and every data point in our data set, if the predicted output, so here we change this, if the predicted output is equals the target output, then we increment our accuracy by 1. At the end, we divide this accuracy by the number of data points. So it means if for every data point our accuracy is incremented, at the end we should have an accuracy of 1, since this accuracy will be m after summing this accuracy m times. So let's take this back, and there we go. We have this evaluate method which has been built. So we'll take this, we come back here. Now note that for this, let's reduce the number of epochs to 10, and then we rerun this. We run in. Since we're just dealing with 10 epochs and not 20,000 as before, our model for now still underfits because we have not trained it for a large number of epochs. With this, there's a value we get for the loss, and then we could say print out the training accuracy. So we have our training accuracy, which is equals this model.evaluate. So we've had our model, and now we're able to evaluate it because we defined this evaluate method in the model class. So we pass in our input x, and then the output, the target output to be compared with. So running this, we have an accuracy of 0.16. To convert this into percentages, we could simply multiply it by 100, then have this %. So that's our training accuracy. With this, we also see that it's important for us to be able to store the model's state at a given point, because we just trained our model over 20,000 epochs and we had a really low loss, like we had a value of 0.09 for the loss, and that accuracy should have given us something greater than 95%. But since we're able to store this model or the model weights at a given point, we now have to restart. Nonetheless, there are possibilities of storing this model weights, and also all machine learning or deep learning libraries actually have functions which help us store the model weights at a given point, so that when next we want to use the model, we don't have to restart the model from scratch as we just did.